Hello everyone, this is the first lecture of Introduction to Programming with Java. My name is Vlad, I will be your instructor and you can find my office and other information here and office hours. If you are an online student, you can always inbox me, that's a good way to start a conversation and ask your questions, or you can use inbox to set up a meeting, and it will be a Teams meeting. And my office hours are scheduled around my classes, and so um, if you call me outside of the regular office hour, you can call me. I'd rather you message me, inbox me, or send an email. But if you call me outside of the office hours, I might not be there. I try to be in my office, and I can meet with you in the afternoon if you make an appointment, including online appointment. Well, there are some useful links here. You can get an idea what we're doing in Java by peeking into my previous Java class. Some of the videos are here in the playlists of Object-Oriented Programming with Java, both CTEC 150 and 151. And this is an 8-week class with the quite an intensity compared to our Python class, probably double. So this is 8 weeks, and you will have more homework, more discussions to participate in, and projects every week. And if you want to kind of see what I was doing in my 150 class last time, actually there is 150 and 151 together. There are some projects, most of the projects that I did, except for maybe chapters 1, 2, 3, because those were not real projects. They were just more basic examples. Although I'm not sure which, yeah. Maybe this is like later project in 150. Play with strings is probably early on, but judging by dates, they may be a little later. Not the very first class. Here is our days off. Spring break, Martin Luther King Day, and Good Friday. And in the syllabus, feel free to read this section syllabus. This is it. What you definitely need to know is that programming discussions and reading discussions are a big chunk of grade. So even though some of them look like a small thing, 1 or 2 points or 5 points, they together constitute 30% of your final grade. Do participate in them. Programming assignments, much like the assignments in the Python class, there will be a verbal description of what you need to do, and your job will be to come up with the code and submit it. Quiz, I think the quiz has unlimited amount of attempts, or at least 2 attempts, and this is a reason for you to interact with code and to see how you understood the concepts and maybe go back, refer to the book again. There are 2 exams. There's, I think, 1 exam actually, or 2 exams, midterm and final. Let me double check real quick before I say it. I think there may be only 1 exam here. Yeah, final exam. And there is no project for this class. There is a project for 151 for the advanced Java. And this is the whole breakdown of the class. You will need a book. There is a bunch of ways how you can get a book from the bookstore online. You can get online access or Google it. And finally, the software, IntelliJ IDEA Community Edition, if you are working on your home computer. with JDK 8. Some of my directions, some of my videos will tell you to install JDK 11. Please install JDK 8 instead, or both of them. If you install one, then you can quickly install the other. You know how to install the other. There are more explicit installation instructions in week 1 module. Over here, you can see the due dates on the assignments. However, a much better way to interact with the course if you are an online student, and in general for anyone to know what's going on and pick up where you left off, is to look through the modules. I'm trying to go to student view. By the way, my policy for the late assignments is 5% of credit off per day. It is a fast-paced class, only 8 weeks, so please do assignments online. And in the end of the semester, I might disable the old assignments so that you cannot take them at all. I don't want to end up with a bunch of late submissions in the last few days of the class. This is just too much to grade. So far, that's all you can see. And let's try the quiz. Unlimited amounts of attempts. But do use the quiz also to practice to see if you understand the concepts and look them up. All right, so please do get the book, and do read the syllabus. I think we are ready to start with IntelliJ. Once you install the IntelliJ, here we are. There is a way to change options and make the fonts a little larger. Let me go back to the modules and show you that there are all book examples here. You can download them and you can open them, download and zip, and then you will be able to open them. So I'm going to open a random assignment from the course. Where are they? All right. Java textbook code, chapter 2, just to show you how to do that. So this examples are actually projects done in a different IDE, that is integrated development environment, I think in Eclipse. And you can open one assignment. Let's not open that one. And instead of just opening like you would in an IntelliJ assignment, it's always safe to just open the source. And that way, it will ask you to trust the project, if you want to trust the project. And that way you can open the file. You have to set up the SDK, and then you can look at the comments here and run it, and it should work. Yes, it does. All right. So that is how you can open the book examples. In any case, the book has nice explanation for its examples. We will use the book examples sometimes when they get really long towards the end of 151 to save some time. For now, I want you to see how to close a project. Here we go. This is what you see. This is what you see when you open IntelliJ for the first time. You won't see any previous projects. And I'm going to, first of all, make sure you have set it up correctly. So let's customize all settings. And the most important one is to disable many of the things about cold folding. In general, You might even disable the file header. I left it be. Definitely disable folding in the classes. Pretty much everything here should be disabled, and that includes generic constructor and method parameter. Once you are very familiar with how generic constructor is written, how it looks like, or method parameters, you can fold them back. The meaning of the folding is the following. When you have some trivial boilerplate piece of the code, which may be actually in IntelliJ automatically generated, and you don't want to keep seeing it, you click here and it will fold it for you. However, I believe it is a bad idea to fold things right away, so try to make sure that pretty much everything in Java is unfolded. And in case you typed up some code and suddenly disappeared, it means that it has been folded, it wasn't lost, but it's a good idea to keep things unfolded while you are starting and learning. Okay, so done with the settings. In any case, in my other installation and configuration video, there may be some other things that you might want to change about settings that I don't recall right now. But all I want is to start a new project. Here is a project. I'm gonna have online program 1, call it anything you like, and choose a JDK. Normally it should be JDK 8. I don't have it yet here, but here we go. Let's see. By default, it's creating a main, and that's probably one of the things that I need to reconfigure before next time. And the main will be hello world. First of all, it creates a public class main. Braces. Notice that IntelliJ highlights together starting brace and ending brace. And inside the brace, we have one static method. So one method which will print out. This is for printing out. Println means print a line, hello world. And when I run it, click the green button here, hello world is printed. Now, a few things to note. If you don't have the run button, it means that you don't have the main, because IntelliJ Java is looking for a main to run. And main, just like pretty much everything else in Java, has to be inside a class. So the class has a name, main. I can change it if I like. For example, I can change it like this to what? Refactor, rename Vlad, just because I wanted to. This is just a name, and this is actually the standard method, main method for programming, and IntelliJ is looking for a main. All right. If I don't like this at all, I can delete the method, the class, the file altogether. Public class has to be in its own file, and the file name and the public class name should coincide. There may be other helper classes inside, which we will not see for a while, I guess, until the 151. But right now I want to delete it. So I go and do save delete. And now I have nothing in the source. So I can start a new class. And in the book, the main class actually is called driver. And just so that you see, I'm going to write a comment. This is a comment line. And to make comment meaningful, PSVM will generate or will provide, it's a shortcut to provide standard, actually public static void main. Don't worry about what these words mean. String bracket that is an array of strings named args. So this boilerplate main method, if I was to say psvm, it already knows main method declaration. Here we are. So you don't have to type everything from scratch. And as we go, there is we should understand the difference between string, printing, just print, and println. So let's do this first. System dot out dot println. You might have to print this a little bit more, type this a little bit more, but after a few times, this will be really your first suggestion that IntelliJ provides. So I will print something like we need x equals 2. And so far, this is just a string. Notice that string actually needs double quotes. You cannot use single quotes for a string. And now I need my x variable. And what would you do in Python? You would say x equals 5. First of all, you need a semicolon in the end of every programming statement. Well, and there is still something wrong. How do you know that something is wrong? First of all, it's highlighted in red. Second, cannot resolve symbol x. Even before you run the program, IntelliJ already tells you what the error will be. If you desperately insist on running the program, it will. Cannot find symbol variable x in the class struct. But the reason is that I did not declare my variable. Int integer variable x and value is supplied, and now this will work as you expect it to work. I should also say that print the actual x value. And to do that, surprisingly, I can add a number to a string, and it will be automatically converted to a string and concatenated with the rest of the string. All right, so now we need x. X is equal to 5. Okay. I'll just say the variable x is an integer, is of an integer. Variable x is of an integer type and is and x equals to, well, the value of x. And rerun this. Here we go. Let's try the next thing just to see how it works. I'm going to say x plus 7. So what will x plus 7 do? Will it first compute the value x, 5 plus 7, 12, and then print well, not quite. So I'll say x plus 7 for consistency. This will not do what we want it to do. So x plus 7 is 5, 7. 5 is converted to a string appended. 7 is converted to a string appended. So that's how this happened. And in order to actually compute 5 plus 7, x plus 7, we have to put parentheses first. So kind of the order of operation applies. We will do this first, and then we will Java will interpret this plus as concatenation of strings. All right, what next? Besides integers, we have float y, and I have to do 1.21, and I have to say f to signify that is float. Float is an analog of float in Python. However, it's not the standard analog. Instead of float, sorry, I said Python and I started to write Python, funny enough. Instead of float, use double. That is a bigger float, so it has more memory to store the float format, and say double 1.21, double z equals to 1.21, and now system out.println z. So get used to using double. This is like double float really, but it's a primitive type, basic type in Java. It works faster than actual float and it gives bigger precision. All right, we will have a more systematic introduction of Java a little later. So far, we are just playing with some examples. Okay, now let us go and do something with IntelliJ. First of all, I can highlight. Let me copy paste Control C. And I'm going to copy paste this code. There is an error because my variable was declared previously. So now if I wanted to somehow restate that z is equal to 1.21, I don't have to do it. If I'm going to say that z equals to 1, it's still okay, but my value z will still be a float, not an integer. Here it is printed as a float, even though I said that z is equal to 1. 1 is an integer, but when we do an assignment like that, Java understands that z is still a float because it was declared. All right, let us split the declaration and assignment. New type, and you can do this with any type of a variable, another primitive type, Boolean, I'll call it S. I declare the variable and the memory for the value of this variable has been allocated. And now all I do, I can separately assign it to be true. Notice that true is not capitalized, unlike Python. There are small differences like that you will need to get used to, but it works. So there are three primitive types that we talked about so far. Integer, float. Actually, float is kind of auxiliary. I'm not going to use it in the rest of the class that much, beyond what I had to say about it. It exists. Double, we will use it, and Boolean. So every time you have a variable, it has to be declared. Which type is it? It sounds like a little bit of an overbearing thing, but it's a good practice. If I declare that my variable s is Boolean, there is absolutely no reason that next time I want it to be hello. I can change every variable, but all the meaningful changes that can happen should be of the same type. The resulting values should be of the same type. That is actually Java enforcing basic good practices. If you need to store hello in a variable, it can be another value of that. All right. What else can we do? For some reason, I might want to comment out this much code. In order to do that, I do Ctrl+/. Let me type it up as a comment to as well, to comment code highlight, then press Ctrl plus and slash. So you press 3 things simultaneously. And if you want to uncomment, highlight, Ctrl plus slash again. Okay. So this is kind of good for a starting example, and in the future, if you need to create a new Java class, create it in the source folder, not out there. So this is another class for now for no reason. Class names are usually capitalized, and it will create a new class, and then you can specify that class and use it in driver. In any case, if you don't like it, or you don't need it, you delete it. Okay, let us do a little run through the slides. So I need to scroll down. The beginning of the book is like a trivial beginning of the book. There's one thing I want to maybe worth emphasizing. The characters have their numerical values, and there is a way to return those values. Oh, oops, I'm not projecting the screen. Okay, so I'm kind of quickly running through the slides. As you may remember from Python, the characters have corresponding ASCII values, like H corresponds to 72, E corresponds to 101, A corresponds to 97. And be aware of that, and in this way, we can estimate how much memory we need to store one character. And actually, the way ASCII is built, you need 1 byte to store a standard character. Of course, for Unicode, you need more. Well, a little bit of math for you. We can see how much bits do we need to store information. For example, if we have 4 bits, this is all the options we have. We have only 16, 2 to the power 4, options to encode information. So if our world, all the information in the world, consisted of 16 different things, each of those things could be encoded by one of these sequences of zeros and ones, and we'd be good to go to describe our little tiny world. And that would be a really boring world. And for comparison, if our world consisted of only 2 bits of information, consisted only of 4 things or 3 things, we could use only 2 bits of information to encode it. Well, 5 bits is 2 to the power 5, there are 2 items, and so on. How many bits would you need to represent each of the 50 United States? Okay, interesting question. Let's look back at this logic. 4 is certainly not enough. It gives us only 16 options. Basically, I need a power of 2, which is bigger than 50. That number is 64, and that is 2 to the power, what? 2 to the power 6. So here we are. That's a solution. Feel free to look in the book. I'm going to skip the hardware networks and go to Java programming language. Yep, Java programming language. So Java is very similar to C#. If you have seen C#, you have a deja vu. For reasons, I'm not going to go into programming, into the history. We will need to use proper programming statements. Your Java program will be made from one or more classes. In the end of Python, chapter 10, we talked a little bit about the classes. This is the same concept, different implementation, slightly different, somewhat different interpretations and choices made. Each class can have multiple methods and also data, the attributes of that class, and a method can contain multiple program statements. So in the beginning, I actually did something with printing. This is a similar example that you can load from the actual file, from the actual program book examples and run it. And if you're curious, look for other examples from other chapters and run it. With Java 8, they should all run out of the box. So you can do comments. I already showed that. Public class my program. This is the name of the class. And in the braces, there is a class body, whatever methods there are, including maybe main method. And here it is, main method. Don't worry about public static. You kind of guess that public means available to anybody. And static means it doesn't depend on an instance. We don't have to create an instance of this class to run the main. We'll talk a lot more about it later, but you need to appreciate that. Let me go back to my example. You need to know basically that blank spaces don't matter unless they are blank spaces inside. I can have blank spaces over here actually. I did not try that for a while because it's a bad practice to do that. Another bad practice, I can put some statements on the same line. The statements are actually separated by semicolon, not by their location. I cannot do that. Undo. I can add a bunch of blank spaces here, some indentation here. So it doesn't matter. What matters is the location of the braces. So this is the analog of indentation in Python, braces. Notice that if I put my cursor to a closing brace, the opening brace will, you will see where the corresponding opening brace is if it's not directly visible, if it's outside of the scope of this window. So it's helpful. In the beginning, you'll have some trouble figuring out where to put braces, what inside the braces, what is outside of it. When you are writing the code, IntelliJ will help you, will make most likely suggestion. It's not always the right one, but it often is. If for some reason IntelliJ is not helping you, it means that you're off with some braces. You may be typing in the wrong place. Okay, let me try to type here. And you see that IntelliJ is not helping me. And also it highlights in the red and makes a suggestion. Does it have any suggestion? System out. Let me just copy paste for whatever reason. So I'm trying to type a programming statement. This is a correct programming statement. It is immediately highlighted and you can check out what the error is. Class or interface expected. So this is not inside any class or or something called interface, which is really a form of an abstract class that is specified in Java for reasons. So that's one way how it tells you you're trying to type a program in the wrong place. Similarly, inside this brace, what's the problem here? Cannot resolve println. Cannot resolve symbol z. Well, it's something about the scoping. Z was defined inside this pair of braces, inside the method, and also inside this pair of braces. So outside, Z is not known. That's a major issue. And let's leave it at that. So as you go ahead and program, you will run into issues like that. And IntelliJ will prompt you what to do and what not to do. It's kind of going to force you into good coding practices, the way IntelliJ understands it, and maybe that's a good thing. All right, so let me show you there is a comment, multi-line comment, /* and finished at */. Feel free to use it. The case variables are case sensitive. The variable can contain underscore and $sign. It cannot start with a digit. It can contain letter, digits, and $sign and underscore. Generally, your variables should conform to a certain convention. And actually, IntelliJ has its own favorite convention. I'm sure there is a way to change it, but I just got used to it. And the convention that IntelliJ is using is if you want to have a variable like total income, 2 words. Of course, there is no blank space between them. Every word is capitalized. And that's the kind of convention I will try to follow. If you want to keep your Python convention with an underscore between the words, that's fine. And now something that you need to be aware of, there are reserved words that are reserved by Java. Each of them have a meaning. Some of them we already talked about, like int, you saw an example, and import, and well, you can see similar ones to those we have seen in Python, like try, while, and so on. So feel free to study this list of words. We will see most of them at one point or the other through the 151. So quick check which of these are valid Java identifiers, and feel free to pause and think about it. Here is the answer. Invalid cannot start with a number, invalid cannot have a hashtag, invalid cannot have an end symbol. As I was saying, white spaces are ignored, and a little bit about program development. Writing the program in a specified programming language, translating the program in a form that computer can execute. So maybe you begin writing by pseudocode or by flowchart. Then fixing various types of errors and writing actual tests for that program. Then finding logical errors when you expected the output of your program to be something and it is instead something else, and going back in a loop and repeating those steps. All right, so let's not talk about various languages. CPU. Each CPU has its own machine language. Assembly is a low level language. I think definitions of high-level language and 4th generation language are slightly iffy. I think Java is high level. And Python is kind of transiting from high level to fourth generation, but feel free to Google and actually uh, uh, establish proper terminology. Now, what we need to know is that program should be translated into a machine language before it can be executed, and compiler is a tool that translates source code into a specific target language. For example, a compiler can be translated from machine language to source code. Well, first of all, Java compiler translates the code into some lower level language, bytecode, Java bytecode. Feel free to look up the examples of Java bytecode online. I don't think we don't get to see them directly in this course or in this book. And Java bytecode is not exactly machine language. It's more like assembler language. And bytecode is executed by Java virtual machine. What that allows to do is basically Java virtual machine will translate the bytecode into the machine code, and Java virtual, as long as there is Java virtual machine on your computer, it should be your Java code can be compiled, and then bytecode will be fed into the Java virtual machine. That way, whatever code you are writing is guaranteed to be machine independent, because Java virtual machine on that actual machine will interpret Java bytecode and execute it on the process. So there are different development environments besides the one that we are using, IntelliJ. IntelliJ, as it is in the name, is quite intelligent. Can be a blessing and a curse, because sometimes make sure you understand what it's actually doing. The book examples, I believe, are written in Eclipse, and feel free to use any other IDE that you like, as long as you are using one and you are successful with it. I'll be able to understand the work that you do. By the way, for the first homework exercises, you can just submit the Java file later in the course, especially for 151. I will want to see the whole project, so you zip the project and you upload it as a submission. Well, every language has syntax rules, semantic rules, and the most kind of errors, even after you fixed syntax rules, the most important kind of errors are logically correct. Or, in other words, semantically correct, which means you have a program, it works, it takes input, produces an output, and it doesn't produce an output that you were intending it to. And then you have to go back and redesign your program. And to see whether your program actually produces the kind of outputs that you want, given the inputs, you have to test it. So just because it works, it doesn't mean it does what you intended it to do. There are two types of exceptions, in other words, errors: compile time errors and runtime errors. As the name suggests, one of them, compile time errors are found during compilation or even before that. So before your Java code runs, it may already be throwing errors at you that you will need to fix. And some errors only come up during the runtime. And again, another warning about logical errors. program ran, did something, and outputs incorrect result. So this is a basic diagram. Feel free to stop and look at it. And this is about where we stopped. We stopped on object-oriented programming. If you did not see much of it yet, that's fine. I will review / talk about it. It's gonna be a little bit before we actually dive deep into the objects and classes, and especially creating our own object and classes. But the entire Java is pretty much objects and classes, standard objects and classes that we will upload from the corresponding libraries. So you will need to have some basic idea about those. And I think that's all we covered today.